Hi, and in today's video, we are going to be comparing two energy-saving bulbs that actually replaced the incandescent bulb, which is the CFL compact fluorescent lamp and the LED bulb. We're going to comparing how it actually works and also which one actually wins. Yes, the two actually claim to have longer lifespan and also save electricity. In this video, we're going to compare it using physics written and logic to know who is the winner and who is actually best to use in our legging pumps. Let's go into the video. Now, I really love to do physical testing on these bulbs, such as using the thermal camera or actually using a watt meter to actually see the wattage actually consumed between the two LED. But unfortunately, I don't have that right now. So we are just going to be using the official rating, the official details actually written on the bulbs and also the physics behind it to actually differentiate the bulb and actually know which one is better and which one you should be using in your homes. Maybe in a while, if this video actually does well, I'm going to buy those stuff and we're going to retest it and we're going to rematch the two LEDs. Let's go into the video. Now, normally this video is actually a comparison video. It's not actually explaining how the bulb actually works, but because of time, I actually made the full video tutorial on how the LED bulb actually works and also how the compact fluorescent lamp actually works. That will be here and that will be here. So anyways, I'm just going to make a quick, very short wrap up on explaining how the bulb actually works. Do not waste time to go to the other video and watch. But if you're done with this video, do want to go check that video to get more insight and very understandable knowledge. Anyways, let's go through it. Now, the LED bulb is actually made with semiconductors. Yes, the LED bulb is actually made with semiconductor. Actually, a semiconductor inside which actually produces the light. Now, this is how it works. When you input your AC power 220 volt as for my country Nigeria, when you input your 230 volt or 220 volt AC into the bulb, it actually goes to the driver. There's actually a driver inside of this LED light emitting diode bulb that actually limit the voltage for it to power to the semiconductor. Now, this voltage flows to the semiconductor and the semiconductor produces photons in form of light you should actually see. That's the quick wrap up on how the LED actually works. If you want to get a full breakdown tutorial, check it right here. Now, talking about the CFL bulb, a compact fluorescent lamp, how does it actually works? Now, it's very simple. I actually made a video about it. The voltage actually goes to it is still the same. The 230 volts actually goes to it like so, and that's actually also a driver inside of this CFL bulb. Yeah, the driver actually boosts the voltage up to 600 volts, which actually feed into these two right here, which is consist of mercury and argon. These high voltage actually excites the mercury and argon, which is actually inside of these two, thereby generating ultraviolet light. Now, this ultraviolet light, we cannot see ultraviolet light, so there's actually a phosphor coating which actually put around the tube that actually turn the ultraviolet light into the visible light. If you want to get the full breakdown tutorial, I actually made a video right here, so go and get the full breakdown tutorial and other explanation which you really need to know. Now, for the compare aspect, these are the list of the things I'm going to be testing. I will be really happy to test it this car, but at the moment I really don't have the tools to test it out. So as I said earlier in this video, we're just going to be getting the original details actually written on the bulb and actually the physics behind them to actually compare the two bulbs. So this is what we're going to compare it, so that the heat produced, instant full brightness time, current draw, power consumption, electricity bill, and stuff like that. So these are the things we compare with between the LED bulb and the CFL bulb. Let's start with the first. Now, talking about power consumption. Firstly, that's the first one which I'm going to compare with, power consumption. Now, as you see here, I'm going to make a video about it. My LED only draws about 3 watts, and yeah, it still gives the same brightness. While looking at my CFL compact LED, it actually draws about 8 watts, which is still really more than the more than the LED bulb. So in another case, the LED bulb actually produces the same light as this CFL bulb, which I'm actually holding right here, but actually draws more current. So the credit actually goes to the LED bulb. This is really short one, but yeah, we quickly go to the point. So we're going to be giving the LED bulb a credit and the CFL bulb is not good. We get animal. We are just getting started and the LED bulb is already beaten up. Anyways, let's just see how it goes to the end. Now, moving on to current draw. We're going to be talking about the current draw. How much current does these two LEDs actually draw? We're going to look first on the LED, then also we're going to look secondly on the compact fluorescent lamp. Now, checking out the video which I actually made right here, my LED bulb actually draws only 3 watts, which I actually said earlier, and also draws about 170 to 230 volts of AC, 50 days. 50 Hz, 50/60 Hz, which actually draws 170 to 230 volts and just 3 watts of energy. Now, calculating the current draw of this LED bulb, you're going to be using the Ohm's law formula, which actually current equals to power divided by voltage. Now, therefore, power is actually equals to 3 watts divided by 230 volts which should give us the sum total of 13 milliamps. Oh my god, just 13 milliamps, which this bulb actually draws. Is wonderful. But here's the twist, we are not done yet. I actually said that the bulb actually draws from 170 to 230 volts. So we actually calculated for the 230 volts VAC, which actually the LED bulb actually draws. Now let's calculate how much current does the LED bulb actually draws at 170 volts. You have to bear in mind that the lower the voltage, the more current the bulb actually draws. Now calculating for the 170 volt, we are going to say current is equals to 103 divided by 170 volts, which we actually have 18 milliamps. Yeah, so this is the range which the LED bulb actually draws, 13 to 18 milliamps of current, which actually draws from the main supply, and not really much. But let's quickly go to the CFL bulb and let's see how much it draws. Now looking at the CFL bulb right here, I actually made a video about it. The CFL bulb actually draws about 8 watts and over 220 to 230 volts, which is kind of vigor. We are almost getting the result, but wait to the end. Also, using Ohm's law in this calculation, also as I said earlier, the current it actually equals to power divided by voltage. So we're going to say therefore current is equals to 8 divided by 220 volts, which we get to our sum total of 33 milliamperes, which is really a lot than the LED bulb in the same brightness intensity. But anyways, let's calculate the second one. Now calculating for the 230 volt, because we actually calculated for 220 volt. Now let's calculate for 230 volts of the CFL bulb and let's see how much amps which it actually draws. Now calculating it using the Ohm's law, we actually have 8 divided by 230 volts and we get the whooping values of about 36 milliamps, which is a lot and more than the LED bulb. Comparing it to the LED bulb, the LED bulb actually draws 13 milliamps to 18 milliamps, and the CFL bulb compact fluorescent lamp actually draws 33 to 36 milliamps of current from my electricity bill, which is really going to pile up my electricity bill. And really it's not really a big deal, and it's not really gonna like spike your electricity bill that much. But looking at the perspective of comparison, which I actually do in this video, the LED bulb actually wins. So we're just gonna give a tick to the LED bulb, and the CFL bulb got this. Now talking about the heat produced, so when they compare, innovation actually generates more heat. And yeah, you know the answer already. I know you guys already know the answer but yeah, we're still going to compare it, and I'm going to explain it why the LED is the cake. Anyways, this CFL bulb actually draws 8 watts and also 230 volts to 240 volts, as I said earlier, while this LED bulb actually draws only 3 watts of energy and draws about 170 volts to over 230 volt VAC by the main supply. Like this is the voltage which actually draws from the main supply. Now talking about the CFL bulb, this CFL bulb actually gets more volts than the LED bulb. Here's what: when the high voltage is being generated by the driver, which is inside of the CFL bulb, it actually excites the mercury and the argon gas, which is actually inside the CFL bulb, as I said earlier in the video. And this excitement actually makes the CFL bulb to actually get very cold. Here's the video clip about someone holding the CFL bulb, and you can see how it really gets quick hot. I will be really happy to use the thermal camera to actually show you the main temperature. But yeah, I really don't have it right now. Maybe in the future we'll do another test. Right now we're just using the physical official rating of the bulbs and also the physics behind that. So yes, this mercury actually excites due to the high voltage which is generated from the transformer and really gets really hot for a period of time. Now talking about the LED bulb, this LED bulb actually draws only 3 watts of energy and around 170 volts to 230 volts of AC, which actually draws. And that we all already tell you that since this bulb actually draws less voltage, it eventually will not get faults than the CFL bulb. So yes, because of the low voltage which the bulb actually draws, because of the low voltage which the LED actually draws, it actually makes it more efficient and produce less heat than the CFL bulb. So again, we are going to say it's actually kind of a tie, because these two bulbs actually get hot. This actually gets a little bit warm and this actually also gets hot, but we're going to give it a little bit tight. It's not actually a full but anyways, The LED bulb is still the king. We're going to give it a tick, and the CFL bulb, we're just going to put kind of, a tie. Now, talking about the instant full brightness, like how long does it actually take for the bulb, each of the bulbs to actually turn on to its full brightness. This one is really short. For sure, the LED bulb actually ons in a second. When you just switch on the switch, it's going to turn on fully. But the CFL bulb, the compact fluorescent lamp, does not work like that. Due to the mercury being excited, it actually takes a little bit longer to turn on to its full brightness before it's actually like with full brightness. But the LED is not like that. The LED does turn on one time because it's actually with semiconductor, but this actually works with gas, so this actually takes more time, and this actually turn on like real quick. So we're gonna give the tick to the LED bulb, and the CFL bulb ticks. Now, talking about the lifespan, I've got to the CZ where we're going to talk about the lifespan. How long does these two bulbs actually last before it actually wear out or before it actually like gets damaged? You should know that this bulb actually doesn't last forever. Yes, efficient, it's more important. It's actually made to replace the incandescent old bulb tigers, but yes, the bulb still doesn't last forever. So that is the one case which you need to bear in mind. As I said in my video, if you haven't checked it, go check it right now on my channel. I said that the LED bulb actually lasts for over 20,000 to 50,000 hours of use time, which is a lot, and the incandescent bulbs actually only last for 1,200 to 2,500 hours, which you really a downfall and really an upgrade for the LED. While the CFL bulbs, actually the compact fluorescent lamp, actually lasts for over 8,000 to 15,000 hours of use time, which is kind of lower than the LED use time, and the LED is still the big winner in this game. And as you can see, the LED actually lasts over 20,000 hours to 50,000 hours, while this CFL bulb actually also lasts for over 8,000 to 15,000. Still good, still efficient, but the LED bulb is still leading in this case. So in this case, we're going to give the light bulb a tick and the CFL bulb a little tick. Now calculating the electricity cost which these two bulbs actually go to consume in a full month. We're just going to be calculating how much does this bulb actually is going to just consume in a month, and how much are you going to pay if you're using each of this bulb, and let's see which one is higher, and we're going to give the tick to that one. Okay, now using the formula, of course, is equals to power, which is actually in kilowatts, multiplied by the time, which is actually in hours, then multiply the electricity rate depending on your country. And for me, for instance, in this video, we're going to be using the US 18, which is actually 0.30 cents per kilowatt, which we're going to be using. Now, how do we get the value? Now, the power which we actually get right here on the LED bulb is actually 3 watts, as I actually said in the intro of this video. So we are going to be putting it in kilowatts. We're not just going to be putting 3 watts right there. We're going to be putting it in kilowatts, which is actually 0.0003 watts. So we're going to put that right there. Now, talk about the hours of use time. How many hours are we going to put? Now, let me say, for instance, we use the bulb for 5 hours in a day. Now, I actually said I'm calculating for a full month. How much do we pay for a full month for this LED? So if you actually use this bulb for 5 hours in a day, it's going to be 5 times 30 days, which is going to come to our value of 150 hours of use time. So yes, we get the time which we actually use. So we're going to put in that right there. And talking about the electricity rating, depending on your country which you're going to be calculating, but for instance in this video, I'm just going to be using the US rating, which is actually 0.13 cents per kilowatt. So we're going to put 0.30 cents right there, and we come to the final value of $0.06. Yes, this is how much we're going to be paid for using this LED in a full month, which is really small. But anyways, we are not going to conclude that until we calculate for the CFL bulb, and let's see how they compare. So now, the watts which this bulb actually draws is actually 8 watts, as I said in the intro of this video. So we are not just going to be putting 8 watts into the formula like that. We're going to be putting it in kilowatts, which is actually 0.0008 watts. So yes, we get the watts. Now, talking about the time of use, we're still going to be using the same as we use in the LED, which is actually 5 hours in a day. So 5 times 30 days, actually a month, we are going to come into the value of 150 hours. So we get the time, and also the electricity rating, which you actually said is actually, we're going to come into the final value, the final answer of 0.16 cents per month. Yes, 0.16 cents per month, which is are going to be consumed by this CFL bulb in a month, and you can already see that it's more than the LED bulb. The LED bulb actually draws only $0.06 in a month, but the CFL bulb actually draws 0.16 cents in a month, which is like more than the LED bulb. So yes, the LED bulb still wins, and we really give it to the LED bulb. Now, coming to the end, we are also going to be comparing the mercury content. Now, looking at the CFL bulb, the CFL bulb actually consists of a mercury, which is actually used as a tool, but the LED bulb does not consist of any mercury, which makes it much better and much safer in environments. The CFL bulb actually consists of the mercury, which is kind of delicate and not good in the environment if you want to dispose it, but the LED bulb is just free of mercury and much good in environment. So we're going to give the tick to the LED bulb, and you know what the CFL bulb is gonna give. Finally, talking about the flickering. Yeah, this CFL bulb actually do flick, you kind of experience kind of flickering, but the LED does not actually flick, and it's just smooth. And so we're gonna give the tick to the LED, and the CFL bulb is gonna get, you know what it's gonna get. So yes, this is the full comparison, and you see that the LED bulb is actually the winner, and the CFL bulb is still a good, compatible, good bulb to use in your homes. It's actually more better than the incandescent bulb. Yes, we agree to that, but the LED bulb is still the future, and I hope you really enjoy the video. Thank you very much for support on Patreon. That will be in the link in the description, and I'll see you in the next one.